Hi, I'm Alan Ross. I'm here at the IEEE PES T&D, that's a lot of acronyms, conference. This is the 2020 version that is actually being held in 2022. These interviews that we're conducting is with thought leaders on the future of the power industry. So enjoy. Our guest for this session is Sandeep Chakrarvarty. Did I get it?
Absolutely.
I nailed it. He is the CEO of Pennsylvania Transformer. We've just been chatting a little bit about things, and we're going to bring that chatting to you. So you're a professional in the industry. I know you've been at Pennsylvania House, almost said it again, Pennsylvania Transformer for 2 years, right?
3.5 years.
3.5 years. But before that, you've been in the industry for a long time. So as a president, as someone whose job it is to, charter a company, move them forward, what do you see in the industry that are the challenges or the obstacles or the opportunities because of all the change that's taking place in the power industry? What do you see looking ahead?
So traditionally, the industry, kind of the T&D industry, transmission distribution, which we are a subset of, that was the growth of the industry was based on the GDP growth. It typically grew at 1 or 2% higher than the GDP. But various other factors are now impacting that growth. One is the aging grid. Now the grid has assets which are much past their expected lifespan, and that's posing a lot of risks to the grid. So they have to be replaced. 60, 70-year-old equipment which utilities have postponed, replacing them, they have to be replaced.
Are you telling me they won't run forever? Built to run 10 years and they've run 60?
They have been, technically we designed it for 30 plus years, but 30, like utilities in the New York area, they have our equipment for 60, 70 years, they're still running it, and they're almost near their end. But of course, they've maintained it well, so which is why they've run so far. Now, on top of that complexity, you have now a different challenges in the grid itself, the quality of the grid. Different loads are being connected to the grid, which creates a lot of turbulence, which means the renewables which go on and off, solar, there's no solar generation at night, and in the daytime you have the solar loads, electric vehicles adding to that complexity. So you need to redesign the grid itself to manage all these complexities, to manage from conventional base load and peak load power plants to sources of generation which are not consistently on. Then you have the issue with with a large push towards green power. Renewable energy is getting connected to the grid, and that poses its own challenges. Again, storage is an issue. You don't have the generation all the time, so storage leads to other complications. How do you, get the energy in when you need it? That type of challenges. Then you have the issue with your new load centers which were not planned before, like data centers, crypto, data mining, etc. Those are coming in a big way in this market. And much of the growth of or expansion of the electric network are to support these areas. And that is creating big gaps in demand supply. So these are kind of the main drivers which is pushing growth in the transmission distribution industry.
So when you look at all these load changes and you look at transients created by a lot of these, which affects power quality, and power quality affects different things differently, right?
Right.
If you're a manufacturing operation and you're using robotics to make something, right? Power quality is going to affect you tremendously. You got to make sure. So somewhere in the network, the power's got to be cleaned up. And a lot of times they blame the transformer. They put it on our transformers to be able to fix the problem, and then it's not our problem. We take power in, we take power out, we do what we do. But in this step up, step down world, that has an effect on transformers.
Transformers by itself are one of the most efficient equipment in the grid. Efficiencies are 99.5%, for larger transformers close to practically 100%. So there's very little loss, and transformers by itself do not contribute to harmonics. It's the industrial load, it's the capacitors, the reactors. These are the sources of generation. So like welding machines, they create a lot of harmonics in the system.
Right.
Or in the renewable industry, because you're converting DC to AC, so you have these inverters which are
Right.
actually creating a lot of these harmonics. So transformers transmit the power the way it receives.
However, doesn't a lot of this harmonics, don't a lot of the transients harmonics and the going from step down to step everywhere, doesn't that age a transformer? Run hotter ages a transformer earlier?
Yes, absolutely. So harmonics tends to create, increase the temperature inside the transformer. So you need to design the transformer to have a very efficient cooling to dissipate that heat within the equipment, and so that has to be factored in. If it is not factored in, then it can age the transformer prematurely.
Yeah. So there's an impact on all of this stuff out here. It doesn't. The transformer is not causing it, but it is impacted by it. Yeah,
by these changes.
And that's what you've got to be looking at. We were talking with Casey Ballard from DuPont, who works in the Nomex application,
Right.
and the idea of using Nomex and FR3 he uses,
Right.
and to create a transformer that can better handle heat.
True.
Because of load, because of all of the things that we've just talked about there.
Absolutely.
Is that something that's happening industry-wide, or is that just unique?
So we are
to
using Nomex very extensively.
Okay.
Most transformers have some form of Nomex. We don't use a full Nomex unless it's a very special application like a mobile transformer.
Yeah.
Mobile transformer is 100% Nomex.
Okay.
Because you're trying to concentrate a lot of power in a small space, and Nomex allows very high temperatures within the equipment. So we can design it very compact, and because it has to fit on a trailer and the trailer has to be mobile, etc. So Nomex is great for those applications. Also for small pad mount collector type substations, I've had experience in the past.
Yeah.
Especially with DuPont itself. We used to own a company in my previous organization called Powell's, and Powell's had a exclusivity with DuPont to develop the slim transformers, which were very compact collector type transformers, which went inside the wind turbine, inside the turret. So they were designed that way, so they could
Lighter?
lighter and compact. That
Okay.
was the main
Yeah.
advantage.
Yeah, that's excellent. If you were to look at across the board, what is the specialty of Pennsylvania Transformer?
So we are a legacy company, started in the 1920s. So we have equipment installed with most leading utilities in the US, pan-US. So we have, in the past, the technology was more shell-type designs. So we have 1000 MVA, 765 kV units installed in this grid. Now, over the years, customers are not replacing the shell type with shell type, they're replacing shell type with core type.
Yeah.
Now we have those designs from the past, so we are using our strength to actually create alternatives with core type designs which are easier to maintain and replace and service in the field.
So primarily large oil-filled transformers.
So that is our strength.
Yeah.
But we have two different facilities. The smaller facilities, we do small and medium power transformer,
Okay.
which basically supports the distribution network.
Yeah.
And some industrial customers. And in Pennsylvania, we do the large and medium and large power transformers.
Okay. What is your lead time?
Lead time in today's world is about 74, 76 weeks, depending on the size of the unit.
Okay, yeah.
Larger transformers than that might be 100 weeks plus.
And we've heard that across the board, right? Lead times are out there. Yet we have money coming in for people to buy to be able to replace transformers. So there's a greater demand and lesser supply. And what are the biggest challenges from the supply chain that you are dealing with right now?
Lead times have gone up across the board. we have we have contracts with our critical vendor base. Many of those vendors have actually gone out of the contract. They're not able to get enough labor force to support their manufacturing, which in turn is affecting us. And what has happened is the entire schedule has got disrupted. Just to give you an example, copper, which is a principal ingredient or raw material for the transformers. Copper is available plenty, but we are not getting CTC conductors. The lead time has gone from 4 weeks to 20 weeks now.
Wow, okay.
Which means I cannot start manufacturing. First of all, my design cycle is 3 months. On top of that, if you add 5 months of lead time, I cannot deliver any unit, even if I have slots, before 10, 11 months. So that's been a challenge.
Yeah.
And so copper, so now initially it was the big things like copper and silicon steel. Now we are seeing disruption in the small components. And this has been a very vicious cycle, especially the last 8 to 10 months.
Yeah, it's challenging. It's a good problem to have that you have orders going through the plant. It's a bad problem to have that you have expectations of more coming out the other end, right?
True.
Yeah,
True, absolutely. And the volatility in the pricing. That's because we are now booking orders 1.5 years down the line. Many of these orders are at fixed prices. We don't know how the commodity market is going to shape up or how the pricing is going to be. So we are taking a lot of risk in trying to price the products and trying to guesstimate how the market is going to be.
Yeah.
So whenever we have a chance, we try to buy, stock up our inventory to support manufacturing.
Right. So talk a little bit about IEEE, and you've been a member for 11 years?
Right.
Talk a little bit about IEEE and the impact on your companies. You've got engineers and the value of IEEE to your company.
Yeah, it's a great forum to network across the entire value chain of the transmission distribution industry, right from, let's say, if the customers at one end and your vendors, contractors, equipment manufacturers. So it brings everybody together in one forum. We have been contributing to IEEE for over 30 years. We are part of the committee on transformers. We see it's a good place to see what is trending in the industry, what standards are being developed, what is being talked about. So it's a great forum. I mean, we appreciate all the value which IEEE brings to the industry as such, and to us, companies like us.
Excellent, thank you. Yeah. Well, thank you for being part of IEEE. Thank you for being right in the midst of the industry and the challenges we face, and being committed to fix those problems and be there when our marketplace needs you. So it's been enjoyable. Sandeep.
Pleasure meeting you, Alan. Thank you so much.